Chapter 2, we're going to rely on a lot of the same skills we used in Chapter 1. The first lesson is just writing and graphing inequalities. So an inequality is basically just a math statement that compares expressions. Now the word compares here is an important one because it's not always checking that things are just equal. It's checking that things are bigger or smaller than each other. So realistically, inequalities are more important than equations for checking things like a business or something. You don't have one working solution. You usually have a ton of options that would work, and you try to pick the best option. So really, inequalities are good for representing the real world better than just equations are. These are our 4 inequality symbols. They have names. This is the less than operator, greater than, less or equal, greater or equal. Although these have names, I can read an equation backwards. So if I have something like x greater than 5, I can also read that as 5 less than x. So one thing I kind of want us to get used to is instead of just memorizing the name and assuming that that is fact, always true, I know it's going to sound childish, but treat it like an alligator mouth. Whichever side it opens up to is the bigger side. So x is bigger. Now if I rewrote this, I'd still say x is bigger because the alligator is trying to eat it. I'll draw that as an alligator. Not a great alligator, but it's eating the x. It's hungry. So I know it's a childish way to think about it, but it works. So think about it this way. Not necessarily so important about the rigid structure of this means greater than or equal to. Now, whatever's on the side that has the open bit is the bigger thing. Following just the plain symbols, we also have some verbal phrases that mean the symbols. If I'm at least as old as someone, that means I am older or equal to their age. So if this is me, and this is the person I'm talking to, my friend, and I say I'm at least as old as my friend, I am older than them or equal in age. More than, I have more money in my pocket. Well, equal doesn't count. If we both have 10 bucks, I don't have more than you. That would be a lie. No greater than. My height is no greater than my friend's. That means we are either the same height or I'm shorter than my friend. No greater than is the less than or equal to symbol. This isn't an exhaustive list. It's just English phrases that mean these things. So try and break down the sentence for yourself. Think of the context. What does it mean to be at least as tall as someone, at least as old as someone? You can match, otherwise you have to be more. So try and break down the sentences that way. When we actually get into solving these problems, we have a new definition for solution. Really, it matches our definition from before. It's just we should expect to get more answers. Our answer isn't just going to be x equals 5. It's going to be something like x is greater than 5, or x is less than or equal to 5. So a solution of an inequality is any value that makes the inequality true. Now, when we're talking about inequalities, we also refer to something called a solution set. This is supposed to be all values, a way of representing all values that make an inequality true. So what's the difference between these two? Well, if I say that I have more money than my friend's got 10 bucks, what's one option that works there? Me having $11 is a solution. All right, this is a solution. The solution set would be a way of representing all possible answers. So if my friend's got 10 bucks, my money greater than $10, that's the solution set. So we'll solve a couple of these and then actually draw them on a number line. The number line will kind of give us a graphic of what the solution looks like. So 11 would be one dot on the number line. M greater than 10 would be shading an entire section of the number line. Here's a couple of equations, inequalities. Shouldn't call them equations anymore. We're going to solve these and then graph them on a number line. Algebra steps remain the same. There is one special rule for multiplying and dividing. We'll get there when we get there. So I'm going to subtract 4 on each side, and the algebra step looks basically exactly the same. There's just a less than symbol instead of an equal sign. Over here, I got to subtract 3. Here's one of those mistakes that quite a few people made. The negative sticks with the m. Oh, hey, look, the special thing happened. So there is a little rule, and we'll focus more on this in the future. But if you multiply or divide by a negative, we have to flip the inequality symbol. So in class, when I have to do this, you'll see me write flip on the board. And in my next step, I'm going to show that I flipped it. So now it's a -7. I flip my symbol, so now it's facing the other way, and then my m. So it stayed the same until I wrote the word flip because I divided by a negative number. That's the one special rule for your algebra steps. Let's see what that looks like on a number line. The first one over here, and your number lines can be really, really simple. I don't need them to be beautiful or detailed. -5, a number bigger on the right and a number smaller on the left. Put a little tick mark on each one. And then we graph the solution. So, a couple little rules. If you don't have the or equal to sign, it's an open circle. If you do have the or equal to sign, it's a closed circle, filled in circle. So this one's an open circle at -5. And then do I want everything smaller than -5 or bigger? My number line represents C. C is the smaller thing. So the smaller numbers are the ones that are going to keep going into the negatives. So down should be to the left. So I usually just really bold up that part of my line I'm shading. I know some people have teachers that taught them to like draw an arrow up like that. Whatever way. It'll be obvious to me which direction you go. The other one over here, similar drawing. I'll put -7 at the middle. -8 is smaller. -6 is bigger. So those will be my 3 tick marks. I do use a closed circle for this one because I have the or equal to. And m is on the smaller side. The alligator is eating the -7. So my m represents the smaller numbers. So I shade to the left again. If my inequality symbol is eating my variable, then I would shade to the right. We'll look at more examples so we get at least one of those. That's basically what solving an inequality looks like, relying on the same exact algebra skills, minus this one special step. I don't think that shows up too much more on this note sheet, but this is going to be almost like a focus of one of the other lessons. Let's do a couple more, and then we'll wrap this one up. 4x minus 25 greater than negative 2. Using my algebra steps, I would add 25 first on each side. 4x is greater than negative 2 plus 25 is 23. Divide by 4. Well, this isn't going to divide out even, but that's fine. Greater than, I can leave it as 23 over 4, but decimals are probably going to be easier for us to use. So this would be 5.75. Where on the number line would 23 over 4 go? Well, to me it's more obvious where 5.75 would go. So let's draw a number line. Put 5.75 in the middle. What's something smaller than that? Well, 5 is smaller than that. What's something bigger than that? 6. So this is between 5 and 6. So the numbers I chose are absolutely fine. I get it's not to scale, but that's not what I'm worried about right now. No or equal to sign. That means I use an open circle. To remember that, I always say that this is easier to erase, so you're not committed. You don't actually want the 5.75. A filled-in circle is harder to erase, so you're committed to it. You do want it. And then my x is the thing the alligator mouth is eating. I want the bigger numbers, so I'm going to go towards the side that's bigger. So hopefully you're starting to get a little bit of an idea what the number line looks like. Last problem we're going to do is going to be a number line that we have to translate into an inequality ourselves. Here's one inequality we're supposed to translate. So we need to identify the number we're comparing to. So x is going to get compared to 48. I just need to figure out what symbol goes in between. Now the shaded side is the bigger stuff, so I want x to be bigger. I'm going to make my alligator mouth eat the x because x is supposed to be bigger. Do I include the line or not? Well, it's filled in. I'm committed. That means I want to use the 48. I want 48 to be an option. So that should be my inequality symbol. The other one they have, same numbers, 44 to 54. This time they have an open circle at 52, and they shade the opposite way. So the application problem that these two come from are about amusement park rides. So the top one would be like a roller coaster you have to be a certain height for. The bottom one would be like for a kid's ride where you're not allowed to go on if you're too tall. So I'm comparing to 52. So x compared to 52 somehow. This time, my arrow's to the left. I want the smaller numbers. So for x to be smaller, the alligator has to face away from it. And do I want the line? I don't want the line. I have an open circle, so I don't want to count 52, so I don't want to be or equal to. All right, so hopefully you're getting a little bit of a hang of these inequality problems. They're let me get that off of the glare. I always forget that there's a glare on the... Should just cover up that light, you know? This lesson should be pretty easy for us. Hopefully the number lines help you understand why there's technically an infinite amount of solutions. But remember, this is called a solution set. An individual one, like if I walk up and I'm like, you know, I'm 5'11", so I'm 71 inches tall. I could ride this ride, but not this ride. I would be a solution up here. This is the solution set. My height would be a solution. So that's just the difference in vocabulary there. All right. If you have any questions, try to remember them for class.